Hello everyone. Today I would like to go through the assembly process of the Hoernle Belt Tensioner. What you see here already now is the full assembly, and also for scale I modeled a racing seat, and you also see some SFX 100 actuators. What you can directly notice is that the belt tensioner itself is pretty small, so it doesn't have a big footprint. You see this because every one of you probably has a racing seat, so you get a very good impression how big the belt tension is. Luckily for me, the model that I downloaded of this racing seat also has 4 different belts, so you can already pretty nicely see where the different belts are going. So if we go here with the front view, you will see that the 2 lap belts that come here from the bottom part of the racing seat will be attached to those rollers on the side. Here the right one, here the left one, and then the 2 shoulder belts that come through the seat openings at your shoulders will come to those central belt rollers. The left one here, and the other one is there. So this is pretty obvious, I would say. What is not so obvious is how the belt tensioner is assembled, and we will tackle this in a minute. But first of all, let's get rid of all the parts that are not so essential to explain that process. So firstly, we hide the 2 different SFX 100 actuators and also the racing seat. And then you just see a bare minimum aluminium rig that you will probably have at home already, and then how the belt tensioner is attached to that. Now, if you look at this from the back, you will not see a clear attachment point. This is also on purpose because I wanted to make it as clean as possible. And you also don't see a lot of the mechanics, and that's due to the fact that the belt tensioner has drive covers, so these 2 central ones and also the side covers here, that kind of try to hide all the mechanical / ugly parts of the belt tensioner. If we turn it now around, which is a view that you usually don't get because you have your racing seat there, but then you see how the belt tensioner is attached to the rig, and these are, at the end of the day, just 4 aluminium angle brackets. And you also have 2 motor mounts here at the bottom. I will come to that in a second. But you see that we have 2 side mounts here, and you have 2 central mounts. These aluminium angles, they are off the shelf, like pretty much everything else that I'm using for the belt tensioner. What you have to do when using these angle brackets is to drill an additional hole, especially for the ones here in the middle, because you can see that the angle brackets have pre-drilled holes, but they are usually utilized when running 2020 profiles. But here it's now a connection between a 2020 profile and a 4040 or 4080. So you have to drill this additional hole, otherwise you cannot use the screw in this position. For the side mountings, now with the version 1.5 of the belt tensioner, there is a difference because you can choose very conveniently where to mount the side pillow blocks. You can also make the assembly very compact, basically reduce the distance between the 2 belt rollers here to 0, and then have the side pillow blocks mounted roughly here, or this aluminum bracket, so you just move it to this position here, and then that's the most compact you can have your belt tensioner. You can also have this when running SFX 100 actuators. You can have the side mounts on the actuator itself. This can have some benefits because it gives you more flexibility when guiding the lap belts around the racing seat. Maybe I bring back the racing seat quickly to highlight the problem here. When we go front view, what you see is that the racing seat usually is pretty wide. So what you have to achieve is to guide the lap belts through this opening here, around the seat, and then into the openings on the side for the lap belts. That's for some rigs quite a challenge. That's why it can be an advantage when you mount these sides on the actuator itself, because it will move the belt rollers, so the lap belt rollers, more to the right and gives you a, let's say, clearer path to the front of the rig. But everything I'm saying here for the side mountings is just a suggestion, and this depends on the dimensions or on the preferences in the different builds. So feel free to be creative. In the model, this is just one option how to mount this. Okay, let's hide the actuators again. And then let's also hide the belt tensioner, or at least one part of it. You will see that the belt tensioner is composed of two different parts. You have a part that tensions the left side, and you have another part that I now hid, which tensions the right part. This makes it then possible to simulate effects like sway. So it's similar, or it's the same functionality that you would get from the commercially available belt tensioners. And this is due to the fact that we're using two different motors here. So the belt tensioner can be run by an 80ST or 90ST servo motor. The one that you see here today is a 90ST, but the model for the 80ST is also available online. Now let's also hide the other part of the belt tensioner and focus on the profiles. In the very beginning, what you have to do is you have to think about how you would like to mount this on the back of your rig. One thing that is not negotiable is the placement of the center profiles, because they just have to be in the dead center of your back profile. What will change, however, is the width of your rig. So in this particular case, between the side profiles, the long ones here, I have now 50 centimeters, but there are other rigs where you have like 60 centimeters or something like that. So measure the distance of your back profile, and then you know where to place the central profiles. You also will see that the central profiles have a gap. This is important because otherwise the left assembly and the right assembly of the belt tensioner will touch, and then there is a lot of friction, or basically the belt tensioner will not work. So this gap is necessary. How to ensure that this gap is always the same? I designed these little spaces here. You can just download it from the homepage and then insert it into the 2020 slots on both sides. So here on the top, but also on the bottom. And then everything should work. The 2020 profiles are then attached to the back of this 4080 profile with these angle brackets and the respective screws and slot nuts. So if you are familiar with how to work with aluminium profiles, this shouldn't be witchcraft for you. What we also should talk about is these aluminium profiles here. They are used to function as an anchor point for the pillow blocks, KP001 pillow blocks. And you will see at the end where to place them, because the distance between the pillow block that goes to the central profile and the other pillow block is predefined by the assembly, so you will automatically also know where to place this aluminium profile. So don't worry about this for now. This brings me to the end of the first video to prepare your rig for the belt tensioner.